Lesson from home today. So hopefully I can get this to work pretty good for you guys. So today we're going to learn about how you can connect molarity and use it stoichiometrically. So let's take a look here at our cans. So last time between the egg lab and last time, we've actually learned all three. That's a horrible circle. But we've learned all three of these ICANNs, 11.1, 11.2, and 11.3. So if you feel like there's one of those that you don't understand and you need more help, please reach out so we can get you caught up on those. Today, in today's lesson and homework assignment, we'll be focusing on 11.4 of using molarity in stoichiometry, and then these are kind of this is kind of what you will do to check and make sure that you know it. Okay? Okay, so with molarity and stoichiometry, let's take a look here at a map. So once again, hopefully this map should look familiar to the one last unit. We've just added this new pathway of molarity, this bottom arrow right here. So you can go ahead and fill this in once again. Grams to moles, that's our molar mass. So here to here, that's always connected through molar mass. This is always connected through Avogadro's number. And then this right here is the molarity piece that we learned last time. So the biggest thing to recognize here is with molarity connects two things together. So the problem is going to give you molarity and you're going to use that to get somewhere else. Obviously everything on this side of the table is the same relationship, and then the in-between bridge, that's connected through the balanced equation and those mole ratios that we see there. So once again, use the map, help it guide you, and then eventually, hopefully if you use it enough, you won't have to use it anymore because you'll just see how the connections are made. So let's go ahead and take a look at a problem together. Let's try this problem. So it says, how many liters of a 0.5 molar silver nitrate are required to react with 3.5 moles of calcium chloride? So just like before, the first thing we want to do is identify what do we know and what are we trying to find so that we can kind of use our map to guide us. So I'm going to circle liters here because that's what it's wanting us to find. And then it's giving us molarity. So this piece of information here is going to be important. But remember that molarity is a pathway. So you don't ever want to start with molarity. That's something that often students get mixed up with. So we're going to use it, but don't ever start with it. The thing that we're going to start with, it says, are required to react 3.5 moles of calcium chloride. So that's what I want to start with. Okay, so if we go to our map here, okay, so keep in mind with our map, if you kind of split it in half, the thing that you're starting with will always be on the left. So I'm starting with moles. So this is where I'm starting. And then the thing you're trying to find is always going to be on the right, which in this case is liters. So I'm trying to get down here. Okay, so let's take what we've underlined and start there first. Okay, change that to green. Okay, so we have 3.5 moles of calcium chloride. Okay, excuse my handwriting on this, but hopefully you can read it. And then the first step is I'm going from moles to moles. So notice I've done that as a blue arrow, so that's my next step. Okay, so notice the bottom pattern still continues, so it's moles of calcium chloride. And then the thing I'm trying to go to is moles of my new thing. So the thing I'm trying to get to is silver nitrate. So it's moles of silver nitrate. Okay? I'm going to keep building and then we can come back for our relationships. So then we're leaving moles of silver nitrate. So once again, notice the diagonals here. And I'm trying to get to liters of the same thing. Okay? So there's so that took me down to there. Okay, so then our mole to mole, so right here, our mole to mole relationship, this connection is always based off the balanced chemical equation. Okay, so I'm looking up there and I see that for every 2 moles of AgNO3, there's just 1 mole of calcium chloride. So we plug those in. Then the liter to mole relationship, or mole to liter relationship, so right here, that arrow is filled in with molarity, which was given here. So the thing to remember is that capital M is that many moles over a liter of something. So that is the same thing as 0.5 capital M. So notice here that 0.5 is in relation to the mole. So in my fraction here, since mole is on the bottom, that 0.5 needs to go on the bottom, and then the 1 goes on the top. So since the mole got flipped, the number needs to get flipped as well. Okay, plug that into my calculator, and I get 14 liters of AgNO3. There you go. Okay, all right, let's try the next one. Okay, so this one says, let's do the same thing, let's circle what we're trying to find. So it says, how many moles of zinc are required to react with 0.2125 liters of a 3 molar hydrochloric acid? Okay, so once again, using my map, I am starting with liters. Whoops. So I'm starting with liters, and then I'm trying to get to moles. Okay, so my pathway is 1 step to there, and then another step to there. So it's going to be a 2-step process. Okay, so let's take the thing that we're given and pull that down first, 0.125 liters. Hydrochloric acid, that's HCl. Okay, we're leaving liters. Once again, diagonal pattern. And I'm going to moles. Okay, next step, leaving moles and going to moles of our new thing, so moles of zinc. Okay, once again, notice the pattern. Liters cancel out liters, moles cancels out moles. The only thing that doesn't cancel is the thing that I have circled up here. Okay, all right, let's plug in our relationships. So the thing that connects moles and liters together is molarity, which in this case is a 3 molar. Now once again, keep in mind that this means that there are 3 moles in every 1 liter. Okay, so since mole is on the top of our fraction, the 3 goes on the top, so it'd be 3 over 1. Okay, the mole to mole relationship, so right here or right here on our map, that's connected through the balanced equation. So the balanced equation tells us that we have 1 zinc for every 2 HCl's. Okay, when I plug that into my calculator, I got 0.19 mole of zinc. Oh, that is a lovely decimal point. Okay, there you go. Once again, hopefully you're feeling that this feels very similar to last unit, because it really is. It's a new unit, but the thing about stoichiometry is it doesn't actually change. The process is the same. Okay, let's take a look at one more here. Okay, so for this part, what I'd like you to do is, if you feel good, go ahead and pause it and try it on your own, and then watch it and check it and see if you did it right. Okay. Okay, so then in doing this one, let's see, it says calculate the number of liters. So once again, let's circle what we're trying to find. So I'm trying to find liters here of lead iodine. Bring that in so I know what I'm trying to find. Produced when 5.5 moles of calcium iodide reacts. Okay, so once again, I'm starting with moles of one thing, and I'm trying to get to liters of something new. So we're going all the way over there. So it's going to be a 1-2 step process. So let's take our starting point. So we have 5.5 moles of Ki, And then we're leaving moles of Ki. And the first step is to change that into moles of something new. So the new thing is lead iodine or lead 2 iodine. Okay, so now I'm trying to go to moles of lead iodine. Okay, I'm then leaving lead iodine and going to liters of it. Okay, got our setup. Once again, we got our diagonal patterns here. The only thing left is the thing I have circled. Okay, mole to mole relationship is the balanced equation. So it's one of those for every two of those. The mole to liter relationship, so this step right here, right, that's the molarity, which is 3 in this case, and it needs to go on the bottom because moles is on the bottom. And then to 1, plug that into your calculator, and I got 0.92 liters of PbI2. And there you go. Yeah, if you have questions on this video before you start the homework, please reach out and let me know. Or as you're doing the homework, or if you plug your answers in and you don't get them right, don't be afraid to reach out. Once again, it helps if you kind of send me a picture of your work so I can see what you're doing. It helps me analyze what's going wrong. But let me know how I can help you. Yeah, we'll see you guys soon. Bye.